As we begin section 1.2, if you have not yet read the text at the top of page 4 from the beginning to the graphs, I'd like you to pause this video and read that text right now. So please do make sure you're reading the text kind of before jumping into these videos. For section 1.2, we're discussing limits. And in our last section, our previous section, we said that when we talk about domain, that the domain of a function is where the function exists. So where the function exists. When we talk about limits, what we're really considering is where the function is headed. So where the function is headed or where it is going. It's not necessarily the value of the function. So I want to actually, before digging into limits, I want to review what I believe you did in Algebra 2 with limits, which was to just talk about end behavior of functions. So if we consider a simple cubic function, I'm just going to say f of x equals x cubed. If I asked you to describe the end behavior of this function, you could do so using limits. And you might tell me that the limit of f as x approaches infinity is positive infinity. Oops, sometimes my infinities look a little, it's hard to do. You might also tell me the limit of f as x approaches negative infinity is negative infinity. So again, if I'm looking at this function, I know what a cubic function looks like. I know that the end behavior, like it's just going to keep heading up in this direction as x approaches positive infinity out here. It's going to head up to positive infinity for the values of f. So they just keep increasing forever. And then, of course, as we go the other direction, as x gets more and more negative, this is going to go down forever. So the value of f will always be more and more negative. Sorry, that's a negative infinity with the highlighter. It doesn't show up very well. So I believe you've talked about limits this way. So again, it's that idea of where is the function headed. We're going to talk about, and we'll come back to end behavior in this unit, but for today, we're going to just talk about limits, or for today. I don't know what day you're watching this video. For now, we're going to talk about limits at a particular value. So we need to talk about the definition of a limit. So I'm assuming that you've read this text. I want to point out that we can talk about one-sided limits. So in this paragraph, we could use this notation to talk about the limit of f as x approaches a from the left. So when you look at this, an a would be a particular value. So maybe a is just the value 4. So as x approaches 4 from the left, it's this negative sign to the right of the a that tells us the direction we are coming from. So coming from the left. And then if there's a plus sign, that's going to mean that we're approaching that particular value from the right. So it's that little plus by the a that tells us we're coming from the right. All right, so when we talk about the limit, so the limit of f as x approaches a, and there's neither a plus nor a minus, that's a two-sided limit. That is the limit of f as x approaches a. So if I look at the definition of a limit, when I talk about the definition of a limit, I'm talking about the two-sided limit. So any function f would have a limit as x approaches a, or at x equals a, if and only if the limit from the left side is equal to the limit from the right side. Otherwise, we would say the limit does not exist. All right, so this is kind of difficult to talk about outside of context. So let's come down to these graphs and let's kind of explore this idea of limiting from a graph together. Because we're going to start off, and I should back up and say we're talking about limits in this section. We're going to be spending a lot of time with limits. Today in this section, we're just going to talk about them graphically, which is, in my opinion, the easiest way. All right, so I'm going to scroll down here. In these examples, we're given graphs of f, g, and h. And hopefully you remember from Algebra 2, these functions are called piecewise. So piecewise defined functions. And what that means is they just look like pieces of other functions. So for example, and I'm going to highlight this and erase it, so don't feel like you need to. Like that piece looks linear. This looks like it might be a square root function. Not really sure. This looks like it could be just some type of polynomial. I'm honestly not sure if this is one function, but it's a bunch of pieces of functions that are kind of put together. And if we need to go over piecewise in more detail, I think we'll have that opportunity in subsequent sections. So for this first row, we're using the function f. So this first row, we're going to look at this first graph, y equals f of x. So in that first example, we're asked to evaluate the limit of f as x approaches 0. So I need to look both from the left and the right. And anything I write on these graphs, I'm going to erase as I go. So if you're annotating along with me, just know that I'm going to erase some of this marking. So as I approach 0, as x approaches 0, rather from the left, and if I go the other direction, as x approaches 0 from the right, this graph right here is going to the same place. And in fact, the y value there, or sorry, the f value there, I guess you could call it a y value, that is in fact 0. So the limit exists because it's the same from the left and the right, and it's equal to 0. For the next one, the limit of f as x approaches 7 from the right. So if I look on my number line, here's 7. If I'm approaching 7 from the right, that means I'm starting over here and coming down this direction. And it looks like we have a vertical asymptote there. So we could say that as we approach 7 from the right, the limit of f, we could say that it's negative infinity. We could also say that it does not exist. When you're writing infinity or negative infinity, I would not put an equal sign there because, again, infinity is not a number. So something cannot equal infinity or negative infinity. All right, the limit of f, in fact, I'm going to say or d and e. All right, the limit of f as x approaches -1. So we have to be careful with our signs here. That's just a -1. That's not approaching 1 from the left. So this is a two-sided limit. So if I go to my graph of f, here's -1. I can tell that approaching it from the left and the right, so coming up to the right and coming down from the left, the function, like the graph is, there's not a discontinuity there. There's not a jump. We'll talk about those later. There's not a hole. So the limit's going to be the same from the left and the right. So the question is, what is it? And you will never usually in this class be asked to like kind of guess at a value. I'm going to say this looks linear. And if this is linear, it has a slope of -3/2, just this piece of the function. So that would mean that that output there, that looks like that would be that looks like that would just be about 1.5 there. Sorry, right there at -1. So I'm going to say 1.5 or 3/2. But if you're feeling like that looks like something different, we're just going to kind of guess. Typically, you will not be asked to do that in this class. You'll have a way to know for sure. All right, so 3/2. All right, the next one, the limit of f as x approaches positive 4 from the left. So on my number line, here is where my positive 4 would be. Nope, that's not where 4 would be. That would be 3. Sorry, here's where 4 would be. I really, like, this is the first one that I think we might really need to pause and think about. As we are coming from the left, so from this direction, again, we've got to get it in our head that the limit is where the function is headed, not necessarily where it exists. So the function exists here at this closed dot. Like if I asked you, what is f of 4? It would be whatever this value is, this closed dot value. And I don't know, it's something that's more than 1. But that's not the question we're trying to answer. The question we're answering is as we come from the left, as we approach 4 from the left, where's the function headed? Well, it looks like it's headed to the value 2. So from the left, this limit, I'm going to say that's a 2 because I think that's maybe a square root function. All right, and then lastly, for this next example in this top row, we're going to evaluate the limit of f as x approaches 4. So now we've got to consider both the left and the right. Well, we already said that from the left, the limit is 2. From the right, it looks like the limit would be 1 point something. I have no idea. We could just say 1.5 if that's what that looks like to you. Again, you won't normally be asked to guess. But what's important is that they're not the same. We can see that those are clearly not going to the same place. So going back to that definition of a limit that's in that box above, if the limit as x approaches 4 from the left of f, if that does not equal the limit as x approaches, the limit of f as x approaches 4 from the right, and in this case those are not equal, then this limit does not exist. So they must be the same from the left and the right. All right, so what I would like you to do is, again, I'm going to actually end this video. I would like you to try the remaining 2 rows. Just be mindful that all of the functions in the top row were about f, so we were using that graph. The middle row, all of these functions are going to be using this graph, y equals g of x. And lastly, the bottom row, all of these are using the third graph. I would hate for you to go through and do them all with the incorrect graph. After this, we'll go over this in the next video.